When providing power to machines with different grounding requirements, it is generally recommended to use a 5-wire system. This means pulling a separate 5th green ground wire from the main service to each disconnect. A 4-wire system consisting of 3 phases and a neutral relies on the neutral wire to carry both neutral currents and ground fault currents. This arrangement can lead to voltage imbalances and safety hazards. By using a 5-wire system, a dedicated ground path separate from the neutral path is created. This ensures proper grounding and prevents the neutral from being overloaded. For machines requiring isolated grounds to minimize noise, for example, the neutral and ground conductors must be bonded together at the service entrance or another designated point upstream from the machine. The isolated ground wire should then be run to the machine. The National Electrical Code, or NEC, section 250.24 requires that the neutral bus be bonded to the enclosure of the disconnect box. Additionally, NEC section 250.96 necessitates a 5th grounding conductor for isolated grounds. The metal conduit between the main service panel and the subpanel functions as a bonding jumper, connecting the subpanel to the main service ground. This connection is generally sufficient to protect the user from electrical shock. However, if the conduit is not continuous or is made of non-metallic material, an additional bonding jumper would be required. To elaborate on the 5-wire system, it provides a more robust and reliable grounding path. This is particularly important in industrial settings where machines may generate electrical noise or experience ground faults. The dedicated ground wire minimizes the risk of voltage differences between equipment, which can be a safety hazard for operators and can also damage sensitive electronic components. When considering isolated grounds, it's crucial to understand their purpose. Isolated grounds are used to prevent electrical noise from interfering with sensitive equipment. By isolating the ground connection, you reduce the potential for noise currents to flow through the grounding system. This is often achieved by using a special isolated ground receptacle and running a dedicated ground wire back to the service entrance. Now let's delve deeper into the NEC requirements. NEC section 250 covers grounding and bonding requirements for electrical systems. It's essential to comply with these requirements to ensure the safety of personnel and equipment. NEC section 250.24 specifically addresses grounding requirements for separately derived systems such as generators or transformers. This section outlines the requirements for bonding the neutral conductor to the grounding electrode system. NEC section 250.96 focuses on bonding requirements for metal enclosures. This section requires that metal enclosures be bonded to the grounding electrode system to provide a low impedance path for fault currents. The metal conduit that runs between the main service panel and the subpanel plays a critical role in the grounding system. It provides a continuous metallic path for fault currents to flow back to the source. This helps to quickly trip circuit breakers or fuses in the event of a ground fault, minimizing the risk of electrical shock. However, it's important to ensure that the conduit is properly installed and maintained. All connections must be tight and corrosion-free. If the conduit is not continuous or is made of non-metallic material, an additional bonding jumper is required to provide a reliable grounding path. A bonding jumper is a conductor that connects two metallic parts of the electrical system. It is used to ensure that all metal parts are at the same electrical potential. This helps to prevent voltage differences that could create a shock hazard. In the example of a subpanel, the bonding jumper would connect the subpanel enclosure to the grounding electrode system. This ensures that the subpanel is properly grounded and that any fault currents will quickly trip the circuit breaker. When working with electrical systems, it's crucial to follow all safety precautions. Always to energize the circuit before working on any electrical equipment. Use appropriate personal protective equipment, such as gloves and safety glasses. If you are not comfortable working with electricity, it's best to hire a qualified electrician. In summary, using a 5-wire system with a dedicated ground wire for each disconnect is generally recommended for providing power to machines with different grounding requirements. This approach ensures proper grounding, minimizes voltage imbalances, and protects both the machines and the user from electrical hazards. Always comply with the NEC requirements for grounding and bonding to ensure the safety of the electrical system. To provide a more detailed explanation, let's consider different scenarios and specific code references. Firstly, let's examine the scenario where you have machines that are sensitive to electrical noise. In these cases, an isolated ground system is often recommended. The purpose of an isolated ground is to prevent noise currents from flowing through the grounding system and interfering with the operation of the equipment. To implement an isolated ground system, you would run a separate insulated grounding conductor from the machine back to the service entrance. This grounding conductor should not be connected to any other grounding points along the way. At the service entrance, the isolated ground conductor would be connected to the grounding electrode system. This creates a dedicated grounding path for the machine, minimizing the potential for noise interference. It is very important that the grounding wire for the equipment be insulated, so it does not contact any other grounded metal. The NEC addresses isolated grounding in section 250.96b. This section permits the use of an isolated equipment grounding conductor where installed in accordance with 250.146d or 250.148. It's important to note that isolated ground should only be used where necessary. In many cases, a standard grounding system will provide adequate protection against electrical shock. If you're unsure whether or not you need an isolated ground, it's best to consult with a qualified electrician. Now, let's consider the scenario where you have machines that are located in different parts of the building. In these cases, it's important to ensure that all of the machines are properly grounded. One way to do this is to run a grounding electrode conductor from each machine back to the service entrance. A grounding electrode conductor is a conductor that connects the grounding electrode system to the equipment grounding system. The grounding electrode system is a network of interconnected electrodes that are buried in the earth. These electrodes provide a low impedance path for fault currents to flow back to the source. By connecting each machine to the grounding electrode system, you ensure that all of the machines are at the same electrical potential. This minimizes the risk of voltage differences that could create a shock hazard. The NEC addresses grounding electrode conductors in section 250.64. This section outlines the requirements for the size and installation of grounding electrode conductors. It's important to note that the grounding electrode conductor must be sized according to the size of the service entrance conductors. In addition to running a grounding electrode conductor to each machine, it's also important to bond all of the metal parts of the electrical system together. Bonding is the process of connecting two or more metal parts together to create a continuous electrical path. Bonding helps to ensure that all metal parts are at the same electrical potential. This minimizes the risk of voltage differences that could create a shock hazard. The NEC addresses bonding in section 250.92. This section outlines the requirements for bonding metal parts of the electrical system together. It's important to note that bonding conductors must be sized according to the size of the circuit conductors. When installing electrical equipment, it's important to follow all of the manufacturer's instructions. The manufacturer's instructions will provide specific guidance on how to ground and bond the equipment. In some cases, the manufacturer may require the use of special grounding or bonding techniques. It's also important to follow all applicable codes and standards. The NEC is the primary electrical code in the United States. It provides detailed requirements for the safe installation of electrical equipment. In addition to the NEC, there may be other state and local codes that apply to your installation. It's important to be familiar with all of these codes before starting any electrical work. Now let's discuss some specific examples of grounding and bonding techniques. One common technique is to use a green insulated grounding conductor. A green insulated grounding conductor is a conductor that is used to connect the metal parts of the electrical system to the grounding electrode system. The green insulation helps to identify the grounding conductor and prevent it from being accidentally connected to other conductors. Green insulated grounding conductors are typically used in branch circuits to ground receptacles and lighting fixtures. Another common technique is to use a metal conduit as a grounding conductor. Metal conduit is a type of raceway that is used to protect electrical conductors. When metal conduit is properly installed, it can also serve as a grounding conductor. To use metal conduit as a grounding conductor, it's important to ensure that all of the connections are tight and corrosion-free. The conduit must also be properly bonded to the grounding electrode system. Another common technique is to use a bonding jumper to connect two metal parts together. A bonding jumper is a short length of conductor that is used to connect two metal parts together. Bonding jumpers are typically used to bond metal enclosures, such as electrical panels and junction boxes. When installing a bonding jumper, it's important to ensure that the jumper is properly sized and that the connections are tight and corrosion-free. In addition to these common techniques, there are many other grounding and bonding techniques that may be used in specific situations. It's important to consult with a qualified electrician to determine the best grounding and bonding techniques for your application. As for the example where you saw sparks when plugging in computer signal wires, it indicates a significant potential difference between the grounds of the computer and the outlet. This is often caused by improper grounding or bonding in the building's electrical system. The fact that the cable shield was tied to chassis ground on both ends exacerbated the problem by creating a direct path for current to flow. In a properly wired building, the ground potential should be the same throughout the system. This means that there should be no significant voltage difference between the ground of the computer and the ground of the outlet. To prevent this problem from occurring, it's important to ensure that the building's electrical system is properly grounded and bonded. This includes ensuring that all metal parts of the electrical system are bonded together and that the grounding electrode system is properly installed. It's also important to check the wiring of the outlets to ensure that they are properly grounded. If you suspect that there is a problem with the grounding of the building's electrical system, it's best to consult with a qualified electrician. They can perform a thorough inspection of the system and identify any problems. They can then recommend the appropriate repairs to correct the problems. Regarding the NEC Handbook Exhibit 250.42, it illustrates a subpanel system for isolated ground. In this system, the subpanel is not directly bonded to the main service panel. Instead, it is connected to the main service panel through an isolated ground conductor. The purpose of this arrangement is to prevent noise currents from flowing between the main service panel and the subpanel. The metal conduit between the main service panel and the subpanel acts as a bonding jumper connecting the subpanel to the main service ground. This is sufficient to protect the user from electrical shock. However, if the conduit is not continuous or is made of non-metallic material, an additional bonding jumper would be required. The subpanel box is bonded to the ground bus inside the subpanel. However, that ground bus is bonded to nothing else. This is because the subpanel is intended to be isolated from the main service panel. The only connection between the two panels is the isolated ground conductor. It's important to note that this type of system should only be used in specific situations where it is necessary to isolate the subpanel from the main service panel. In most cases, a standard grounding system will provide adequate protection against electrical shock. It's also crucial to differentiate between equipment grounding and the neutral conductor. The equipment grounding conductor is for safety, providing a low impedance path for fault current to return to the source, tripping the overcurrent device circuit breaker or fuse. The neutral conductor carries the unbalanced current of the normal load. These two should only be connected at the service entrance or the source of a separately derived system like a generator. Connecting them elsewhere can create unwanted circulating currents on the equipment grounding conductor, leading to safety hazards and potential noise problems. Different types of conduit have different grounding characteristics. Rigid metal conduit RMC and intermediate metal conduit INC generally provide a good grounding path due to their robust construction and tight connections. Electrical metallic tubing EMT can also be used as a grounding conductor, but it's important to ensure that all connections are properly tightened. Flexible metal conduit FMC and liquid-tight flexible metal conduit LFMC may not provide a reliable grounding path, especially over longer distances. In these cases, it's necessary to install a separate grounding conductor inside the conduit. Non-metallic conduit, such as PVC, cannot be used as a grounding conductor. In these cases, a separate grounding conductor must be installed inside the conduit. It's important to consult with a qualified electrician to determine the best type of conduit for your application and to ensure that the grounding system is properly installed. Remember, electrical work can be dangerous. It's always best to hire a qualified electrician to perform any electrical work in your home or business. They have the training and experience to do the job safely and correctly. To reiterate the original question, whether it's safe for machine and user to use 4 wires, 5 wires, or either depends on the specific application and the requirements of the equipment. In general, a 5-wire system with a dedicated ground wire is the safest and most reliable option. This approach ensures proper grounding, minimizes voltage imbalances, and protects both the machines and the user from electrical hazards. However, in some cases, a 4-wire system may be acceptable, especially if the equipment does not require an isolated ground. It's important to consult with a qualified electrician to determine the best wiring system for your application. They can assess the specific requirements of the equipment and the electrical system and recommend the appropriate solution. They can also ensure that the grounding system is properly installed and that it meets all applicable codes and standards. When designing or modifying an electrical system, it's essential to consider the long-term safety and reliability of the system. Proper grounding and bonding are crucial for preventing electrical shock and ensuring the proper operation of equipment. By following the recommendations outlined above and consulting with a qualified electrician, you can create a safe and reliable electrical system that will serve you well for many years to come. In your specific situation, given the age of the building and the addition of new machines with potentially sensitive electronics, a 5-wire system is highly recommended for the new disconnects. Running a separate, insulated equipment grounding conductor to each disconnect provides the best protection against voltage differences and noise issues. This approach aligns with best practices and helps to ensure a safe and reliable electrical system for the machines and the operators. Always consult with a qualified electrician or electrical engineer to ensure that the installation meets all applicable codes and standards.